Welcome to this video on Assemble States. After completing this video, you will be able to explain how to create input features to construct and assemble the state. In the previous video, you learned about the various input features to construct states. These states reflect the current market conditions, and you make trading decisions based on that. Remember the idea of gamification, where we treat each trade as an individual game. Each step in the trading game requires the assembly of a new state. For example, you will construct a state on July 10, 2002 11 a.m., and again at 11:05 a.m., and so on. You have to construct the state such that it can be fed to artificial neural networks. Then, artificial neural networks predict whether to buy, sell, or hold based on the state. How to construct such a state? The game class receives the open, high, low, and close data with 5-minute granularity. This 5-minute data is used to create candles of lower frequency such as 1 hour and 1 day. This can be done using resample method. We have already learned this in the init method of game class. The first input feature in state is Candlestick. Let's say we are on July 10, 2002 11 a.m., and we are required to construct the state. We take the 5 minutes candle data. Extract the last 10 candle bars before 11 a.m. In the code, this is done using getEndTimeBars method. Next, we flatten this data frame into an array as the neural network works well with the vector as input. This can be done using the flatten method of NumPy library. The flatten array has 40 values for open, high, low, and close for the last 10 candles. Can we pass this data as it is to the neural network? Remember, we discussed in previous videos that input data needs to be stationary. We make the price data stationary by taking z-score of it. The same process is repeated for the candles with 1 hour and 1 day granularity. This takes the size of the input vector to 120, 40 input vectors for each granularity. Next, we add technical indicators. As discussed in the previous units, we use 5 technical indicators. These are the percentage change between two moving averages, relative strength index, momentum, balance of power, and the Arun oscillator. We use the technical analysis library, TALib, to calculate these indicators. Each of these 5 indicator values is calculated for different granularities of data, which are 5 minutes, 1 hour, and 1 day, to provide a wide range of feature values. With these we add 15 values to the state vector, taking the size to 135. Finally, to complete the state vector, we add the day of the week and time of the day as input features. For calculating the day of the week, we consider Monday as 0, Tuesday as 1, and so on. We also add the current position of the trading game to the state vector, taking the size of the final state vector to 138. All these steps are performed in the assemble state method. Finally, you can get the state vector using a utility method getState. That's all for this video. Later in this section, you will learn to create state and assemble them in the Jupyter Notebook.